Weather forecasts help all of us to plan our lives and stay safe. Scientists are continually trying to improve the accuracy of those weather forecasts, and one way of doing that is to collect observations from the air in an aeroplane like this.
A group of UK scientists and the Met Office have received funding from the Natural Environment Research Council's Storm Risk Mitigation Programme to conduct studies into storm systems approaching the UK. Using a research aircraft to carry out numerous experiments, they hope to improve forecasts so that small areas of particularly heavy rain or high wind speeds can correctly be located within large storm systems. But this level of accuracy is a challenge.
One of the things that people are very concerned about at the moment is extreme rainfall, because it's a hazard in itself. It's a hazard for flooding, bridges collapsing, and that sort of thing. We're now pretty good at predicting things on the scale of the British Isles, for example. We know that it's going to be rainy tomorrow, but we don't know, or the final challenge is it going to be raining in Cornwall, or is it going to be raining in the Pembroke coast? And we're particularly interested in the mesoscale, which is basically on scales of tens to hundreds of kilometres. That's kind of the final frontier for forecasting.
So forecasting rainfall is clearly very important, but is it so hard to predict where rain will fall?
Yes, yeah. It is a very hard thing to forecast and to get right, because it is, they're so tiny. The droplets that form these raindrops are so small, and weather models, historically, have struggled to get this right.
Here we have a comparison of some forecast precipitation fields from a short-range model and a radar image, which is basically what has happened in real life. And you can see that in both the radar and the forecast that there's some blobs of organised rainfall, as it were, but they're not always in the right place or at the right time. So what we're trying to do in this project is very much look at what worked well when the forecast worked well, and what let us down when the forecast didn't verify properly.
The team are also investigating high wind speed events and were able to collect measurements from a severe December storm which caused widespread disruption across northern Britain. The computer model failed to show the true strength of the storm 2 days ahead, but with 12 hours to go, the model provided a very accurate prediction, allowing the relevant warnings to be issued.
One of the things we're trying to do in this project is make genuine advancements with our project partners, the Met Office, in improving forecasting. And what we're concerned about in a changing climate is the number of extreme weather events going to change?
The aircraft has a staggering number of instruments both inside and outside, so what kind of measurements are being taken?
Most of the instruments I'm running this week give images of the cloud particles. This is really important because it can tell you when the particles formed, where they formed, how likely they are to turn into rain.
We have over 100 parameters that we can view in flight on here. So it's a pretty big bunch of instruments and measurements. There's no other way of measuring the weather as such as to go and fly in it. You can't look at the microphysics of that cloud without physically flying into that cloud.
During this project, we've done a couple of flights where we've been flying along at 150, 200 feet above the sea surface, which is quite entertaining, a lot of fun.
I love flying. So one of the perks of the job, getting to do a bit of travelling with the aircraft, which gets you away from the desk, and get to lots of nice exciting things.
It's research projects like this that increase our knowledge of atmospheric science and ultimately help us deliver increasingly accurate weather forecasts.